So the question is, how can I use Pascal's triangle to expand a binomial? So let me take a look at this problem. So example number 1, right? I want to expand this problem, y minus 2 to the power of 5. Now, first thing I could do is I could write out y minus 2. I could write it out 5 times, and then I could multiply those binomials 5 times. But I don't want to do that. Okay, so I want to use what I thought about. So I'm going to use Pascal's triangle. I'm going to use these coefficients, so notice 1, 5, 10, 10, 5, 1, because my highest power was a 5. And then I'm also going to use what's happening. In each expansion there are n plus 1 terms, so I know there should be 6. And that as my x's decrease by 1, my y's are going to increase by 1. So what I'm going to do first is I'm going to write a quick little let statement. I'm going to let a equal y, and I'm going to say b is going to equal negative 2. So what's happening? The first thing I'm going to do is I'm going to write it out with my Pascal's triangle. So I'm going to say 1, because my coefficients always start with 1. It always starts with my highest degree is a power of 5, and then b would be a power of 0. So if we add those together, I will always have 5. And then Pascal's triangle says my next number will be 5. So this will be 5. My a's are going to go down by 1, and my b's are going to increase by 1 each time. My next number is a 10. So this will be 10a to the power of 3b squared. And since I already looked to see that it was also another 10, right? So 10a squared b cubed. And my numbers are going to go up. They're going to reach a point, and then they're going to start coming back down. So 10 was my point. So I know that I'm going to come back down. So 5a to the power 1, b to the power 4, plus 1, a to the power 0, b to the power 5. Why I did that is so then I could write out my general binomial expansion, right? And then what I'm going to do is I'm going to replace everywhere I see an a, I'm going to replace it with y. Everywhere I see a b, I'm going to replace it with negative 2. Now, let's think about this logically. B to the power of 0 is equal to 1. A to the power of 0 is equal to 1. So that's one place I don't have to worry about it. So this will just become 1 times y to the power of 5 plus 5 y to the power of 4 times negative 2. Now negative 2 to the power of 1 just stays as negative 2. Plus 10 times y cubed times negative 2 squared plus 10 times y squared negative 2 cubed plus 5 times y negative 2 to the power of 4 plus 1, and then y would go away, so this will just be negative 2 to the power of 5. Now, when you raise a variable to an exponent, it's not going to change anything. 1 is not going to change anything either. So this will just end up being y to the power of 5. Here, this will be 5 y to the power of 4 times negative 2. So I'm going to end up multiply those together in just a second. This will be 10y cubed times positive 4, right? Because negative 2 times negative 2 gives me positive 4. Here, this will be 10y squared times negative 8. This one will be 5y times a positive 16. And then 1 will just go away, so this will be negative 32. Right? Again, so notice now my y is 5, 4, 3, 2, 1, 0. Right? Now you just have to multiply these. So I have expanded so 5 times negative 2 is negative 10. So you can either put plus, or we can say minus. So let's say minus 10y to the power of 4. 10 times 4 is a positive 40. 10 times negative 8 is a negative 80. And then 5 times 16 is a positive 80. and then minus 32. There are no terms to collect. Notice that it's a power of 5, so I should have 6 terms. I got 1, 2, 3, 4, 5, 6. So I have correctly expanded this binomial. Right? So it just makes life easier, so I don't have to necessarily worry about writing it out 5 times. So let's try example number 2. So I want you to expand this binomial. So we're going to say x squared plus y squared to the power of 4. So you can either pause the video and try this out. All right, so I'm going to write a quick little let statement. Let a equal x squared. B is going to equal y squared. So we use a power of 4. I'm just going to draw a quick little Pascal's triangle in the corner. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There we go. That's all I need. So this will be 1, a to the power of 4, b to the power of 0, plus 4a cubed, b1, plus 6a squared, b squared, 4a to the power of 1, b cubed, 1a to the power of 0, b to the power of 4. Everywhere I see my a, replace it there, b, replace with there. 1's not going to change anything. X squared to the power of 4. And this will be x, oops, forgot the squared sign. So take that away. Cubed, y squared, 6, x squared squared, y squared squared, x, oops, messed up again, x squared, y squared cubed, and then plus y squared to the power of 4. So when we raise a power to a power, we multiply. So 2 times 4 is 8. So this will be x to the power of 8. Don't have to worry about multiplying the number 4 by anything. So 2 times 3 is going to give me 6, and then y squared. And then this will be 6x to the power of 4, y to the power of 4. 4x squared y to the power of 6. And then y to the power of 8. Power of 4 should have 5 terms. 1, 2, 3, 4, 5. Right? Notice that all the terms add together to give you 8. So 8 plus nothing is 8. 6 plus 2 is 8. 4 plus 4 is 8. 2 plus 6 is 8. All right. Let's try one more problem. All right, so example 3. So let's try 2x plus 3y to the power of 3. So go ahead, pause that video and try this problem out. Okay, so let's try this out. So this will, again, let's just quickly draw our Pascal's triangle off to the side. So 1, let's do it in blue. So let's first erase this. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's as far as we need to go. So what does that look like? This will be 1, a to the power of 3, b to the power of 0, plus 3a squared, b to the power of 1, plus 3a, and then b squared, plus 1, a to the power of 0, b to the power of 3. I forgot to write a quick little let statement, so let a equal 2x, b will equal 3y, just so we know what we're dealing with. So this one you have to be careful about because you not only have to raise x to the third power, but you also need to raise like 2 or 3 to those powers. So this will be 1 times 2x cubed, and then plus 3 times 2x squared. Oops, almost forgot the b. And then 3y. This will be 3 times 2x times 3y squared, and then 1 times 3y cubed. So 1's not going to change anything. So 2 cubed is 8. X cubed is x cubed. Here this will be 3 times 4x squared times 3y. Here I'm just going to multiply this together. So this will be 6x times 9y squared. And then finally 27y cubed. Last but not least, this becomes 8x cubed. And we'll multiply 3 times 4 is 12. 12 times 3 is 36. X squared y, again 3 to 2. This will be a 1. 54xy squared. And then 27y cubed. Right? Again, this has a fully expansion of our binomial. Now, if you want to sit here and multiply it out 3 times, that's fine. But using Pascal's triangle is a lot easier to expand than trying to multiply it out each time.